Hey everybody, this is feature scaling with sklearn, and what we will be looking is how to do feature scaling with the available functions in sklearn. So before we look into the available functions of the code, we'll just look into why we need to do feature scaling. So in our input vector, like if our input vector has the data in the range of millions or let's say thousands, and other vectors in the range of tens or hundreds, the model can be biased because of the difference in the range of values. So if you look at the data, like for example, we've got site visitors on a website, or let's say the footprint of people walking into a mall, or let's say video views of a YouTube videos. These can be in the range of millions or hundreds of thousands, and other input vectors can be in the range of let's say tens and thousands. So this can kind of make a model biased, and this is kind of the reason why we do model feature scaling. So what we'll be looking into is the code implementation. How do you use this using sklearn? And that's what we'll do now. So say we are looking into the website visitors data. So I'm going to import pandas now to create a data frame. So I'm going to say import pandas as PD and create a df equals pd.dataframe. And I'll say site visitors equals, let's just create some random values. So I'm going to say from random module, so random import rand int. I'm going to say rand int of, let's say, from 100,000 to 1,000, that's 100,000, to let's say a million. That's our range for item, or let's say underscore in range of, let's say, 10, so 10 values. And we have this. So if we just print our data frame, we'll just see how that looks. Okay, we've got some huge values in the range of 100,000 to a million. And what we will do is see how to implement the feature scaling methods, right? So what we'll be looking into three modes of feature scaling, right? Which is, the first one is, just put down the comments here. So first one, we got standard scaling, which is also known as z-scaling. And we've got the second method, which is min-max scaling. And the third one is robust scaling. Now you can always go ahead and take a look at what each of these do, right? Each one will take an individual video, so we won't be looking into the details of that. We'll just see how can I implement the values for this, and we need to import these methods that are the classes that are available in sklearn. So I'm going to say from sklearn dot pre-processing, that's where this is stored in. Import standard scaling, min max scaling, min max scaler. Okay, so that's standard scaler. There you go. And we've got robust scaler. Okay, and what we'll do is the code implementation is actually pretty much the same, right? So it's not very easy. It's not very difficult to kind of remember. So I'm going to say s equals standard scaler. I'm going to create instances of each. I'm going to say m equals min-max scaler, r equals robust scaler, right? And each of them has a fit transform method that takes in a data frame. So I can say df of, let's say, standard scaling. I'll add a new column equals s.fit transform, and it takes in a data frame. So you got to be careful there. So you can just say site visitors. Okay, cool. So I'm going to say create two more. I can say min-max scaling, and I can say robust scaling, and just replace these with m and r, and not okay, that's r. I can just print the data frame and see what we get. There you go, right? So this is all you need to do if you want to kind of scale down your input vector values, and choosing the one that you need, which is standard scaling or min-max or robust, is actually depending on your needs. Thank you so much for watching.